diffraction magnetometer tan C position. The aim of the experiment is to determine the pole strength and the moment of a given bar magnet using diffraction magnetometer in tan C position. Now diffraction magnetometer in tan C position, here the magnetometer is arranged in tan A position itself, but the magnet is kept in a vertical position. That is the difference between tan A and tan C position. Now as we know, in the case of a diffraction magnetometer, the magnetometer consists of a compass box which is placed at the center of a wooden board of 1 meter long, and the compass box is provided with a magnetic needle at the center, which is pivoted at the center, and a long aluminum point is also pivoted at the center perpendicular to the magnet, and the circular scale is graduated into 4 quadrants from 0 to 90. So in order to adjust the magnetometer in tan A position, initially the adjustment is such that we can rotate the compass box such that the 0 reading of the compass box is parallel to the arms of the diffraction magnetometer. 0 line is parallel to the arms. Then the whole apparatus is rotated so that the aluminum pointer reads 0. Then the diffraction magnetometer comes in the east-west direction. That is, in the tan A position, the magnetometer is in the east-west direction. Now to use the magnetometer in tan C arrangement, the only difference is we are placing the magnet vertically. When such a magnet is placed vertically, it produces a magnetic field at a distance d. Now the magnet is at a distance d from the center of the compass box. At the center of the compass box, already BH is existing. This magnet produces a magnetic field B which is perpendicular to BH, and that magnetic field is given by the formula mu 0 by 4 pi m into 1 by d square minus d by d square plus L square raised to 3 by 2, where d is the distance of the magnet from the center of the compass box. The distance is measured to the center of the magnet, and capital L is the total length of the magnet. Capital L is the total length of the magnet. So that is a formula for B. Now this B is equal to BH tan theta. We can equate these two. Now from that we can determine the value of the pole strength. Here M is not the magnetic moment, M is the pole strength. The pole strength M is calculated using the formula 4 pi by mu 0 BH tan theta divided by mu 0 into 1 by d square minus d by d square plus capital L square raised to 3 by 2. That is the formula for pole strength. Now the moment is calculated by the formula pole strength into the total length L of the magnet. Now coming to the procedure, the diffraction magnetometer is arranged in the tan A position. We mentioned how it is arranged. So it is arranged in the tan A position. Then the magnet is kept at a distance d in a vertical position. Then we can take the readings on the compass box. We are getting 2 readings. Then the magnet is reversed. Then we are getting 2 more readings in the other 2 quadrants. So the magnet is kept in one side of the diffraction magnetometer. We are getting 4 readings. Now the magnet is kept on the other side of the diffraction magnetometer. We can have 4 more readings for one position, and then in the inverted position. So we are getting 4 more readings. Totally we are getting 8 readings. We can take the average of the 8 readings. Then knowing the value of L and using the above formula, we can calculate the moment of the magnet. Now coming to the observation tableau column, we are repeating the experiment for different distances. Say distances 14 centimeter, 15 centimeter, etc. We are obtaining the diffractions, mean theta, and the pole strength is calculated. And then we can obtain the result, both pole strength and moment of the magnet. Now in tan C position, the diffraction magnetometer is arranged in tan A position itself. So for tan A arrangement, we have 2 arrangements. First one is the rotation of the compass box. Then we have to rotate the wooden board. So initially the compass box is arranged such that it is rotated so that the 0, now one 0 is here, now the other 0 is here. Now the 0 line should be parallel to the arms of the diffraction magnetometer. The 0 line is parallel to the arms of the diffraction magnetometer. So here I rotated the compass box and made the 0 line parallel to the arms of the diffraction magnetometer. Then secondly, we are rotating the whole apparatus. The whole apparatus is rotated so that the aluminum pointer reads 0. So we want the aluminum pointer to read 0, 0. For the whole apparatus is rotated. Now you can see the aluminum pointer is reading 0, 0. Now one 0 is here and the other 0 is here. Now the aluminum pointer reads 0, 0. Now the diffraction magnetometer is arranged in the tan A position. Actually we are using the tan A position for the experiment tan C also. So that is arrangement of the diffraction magnetometer. Now we are bringing the magnet, and in the tan C position the magnet is kept in a vertical position. The magnet is kept vertically on the arms. Now we can adjust the distance. The distance is measured from the center of the compass box to the center of the magnet itself. The magnet should place symmetrically and at the center of the scale. Now the distance can be such that the initial value of the diffraction magnetometer is nearly 60. So here I am placing at a certain distance. Let the distance would be 13 centimeter to the center. Now the distance center is at 13 centimeter. So here I am getting two deflections. So one of the deflection is 57 and the other deflection is also 57. So we mark the deflections as 57 and 57. So we obtain two readings. Then just reverse the magnet or invert the magnet and kept at the same distance, say 13 centimeter. Kept at the same distance 13 centimeter. We are getting two more readings. So here I am getting a reading of 58 and again here I am getting another reading of 58. So that two more readings are noted. So I got four readings when the magnet is placed in one side, that is in the eastern side. Now the magnet is shifted to the other side and kept at the same distance 13 centimeter. Kept at the same distance 13 centimeter. Then we are supposed to get four more readings. Now the magnet is placed at 13 centimeter. Now you can take the readings of the two quadrants when it comes to rest. Now here we are getting the reading. The reading is 57 again, and here also 57. We obtain the fifth and sixth reading. Fifth and sixth reading. The magnet is again inverted. Magnet is again inverted and placed at the same distance. Then we are getting the other two readings, the seventh and eighth readings. That's also 57 and 58. So for a distance of 13 centimeter, we got 8 readings. We can calculate the mean of that 8 readings, mean theta, and from that the pole strength M can be calculated. Now we want to repeat the experiment. Now we are changing the distance to a distance of 14 centimeter. We are getting readings 1, 2, then it is reversed, magnet is reversed. We are getting the reading 3, 4. Then the magnet is brought on the other side and kept at the same distance 14 centimeter. Sorry, at a distance of 14 centimeter. Then we are getting the reading 5, 6, then the magnet is reversed, then we are getting the reading 7 and 8 reading. So for a distance of 14 centimeter we obtain 8 readings. Then it is repeated for another distance, say 15 centimeter, then another distance, say 16 centimeter, and another distance 17 centimeter. For all these distances we can get 8 readings, and the mean of 8 readings, mean theta is calculated and tan theta is then calculated. Now coming to a sample set of readings in the tan C position. The length of the magnet, that is 2L, that is marked as capital L, that is 7.6 into 10 to the power minus 2 meter. Then the readings. Initially we place the magnet in a vertical position. The magnetometer is arranged in a tan A position. The magnet is kept in a vertical position, then it becomes tan C. So for the initial readings I got 57 and 57. When the magnet is inverted and kept on the same side, the readings are 58 and 58. The magnet is kept on the other side of the diffraction magnetometer, then the readings are 58 and 57. Then again the magnet is inverted, the readings are 57 and 58. So the mean reading is 57.5 and the pole strength is calculated using the formula 4 pi by mu 0 BH tan theta divided by 1 by d square minus d by d square plus L square ratio 3 by 2. We know all the quantities. Mean tan theta we obtained. D, the distance is 13 centimeter, and L, 2L, that is 7.5 centimeter, that is 2L. So after substituting we obtain the pole strength 28.17. Now the experiment is repeated for another distance, keeping the magnet 14 centimeter, 15 centimeter, 8, 16 and 17. We obtain for each distance 8 deflections and mean deflection, and the pole strength is calculated, and the mean pole strength is 28.91, and so that's our result. From that we can obtain the moment, pole strength into 2L, 28.918 into 7.6 into 10 over minus 2, that is the 2L or length. So that is moment is 2.19. So that is our result. Pole strength and moment of the magnet are calculated.